Mr. Wolf.
Yes, sir.
The inverse trig functions, the Unit 8 Worksheet 5 stuff with pre-calc-BC, whatever, is that due tomorrow?
Yeah.
That's just action practice.
All right, so part 3 of the review trilogy. So, gentlemen. All right, so number 3, x e to the negative x squared. Usually when we have an e, we pick u to be the exponent and kind of hope that the rest of it works. So if u is negative x squared, du is negative 2x dx, and so yeah, I would say that worked. Remember, you have to think like 3 things in mind when you're picking u. You want to pick u to make your life easier for the integral. So that's one thing. You want to pick u to make your integrand simpler. You want du to show up to make the integrand simpler. And you want the integrand to be something that you can integrate. And so you kind of have to think about all 3 of those things while you're picking u. But this one's pretty close. We can spawn in the negative 2 to make the du show up. So that negative 2x and dx make the u. We picked negative x squared to be u, and we still have a negative 1/2 out front. And this is how u substitution is supposed to work. Right? You pick something for u, it makes the integrand a whole lot easier and recognizably easier. Like, I know what the integral of e to the u is. It's just e to the u plus c. And we talked about that that's a safe stop because you've identified what u is. For multiple choice, they're almost certainly going to plug the x stuff back in there. So safe stop, multiple choice, but those are the same thing. Number 6. What do you want to do first on number 6? Divide. How did you know to divide? If it's bigger or equal on top, then you have to divide. Am I eligible to synthetic divide on this guy? No, because there's x squared. So, lovely. I've got to do the long division. We're missing an x squared term. So don't forget to throw that in there. Okay, so something times x squared gives me x cubed. That would be x. Multiply it back. X cubed minus x. But then we subtract those, so change their signs. The lead term should always cancel out, right? That's why you picked x to multiply, make that happen. 0 goes away. Negative 2x plus x is negative x, and bring down the 1. And then something times x squared minus 1 is supposed to give me this. No, that doesn't work. So that's so that's the remainder, which we'll put over x squared minus 1. Now, did I do something wrong here? Because this is not working like I want it to work, I don't think. So x plus negative x plus 1 over x squared minus 1. Whoops, I shouldn't put that there. I should put it all the way at the beginning. Okay, I can promise you that that's going to be an answer choice tomorrow or Friday, I don't remember, where people, they remember to divide, but then they forget that they actually need to take the antiderivative. So, yeah, that's the right first step, but it's not the only step. We need to keep going. Did we do? I don't like this problem because this is more than this is. It's like this part's easy. That's x squared over 2, right? No problem.
Can you reduce the fraction? Or can you not use its own limit?
I can reduce that. There you go. That will make life easier. So that would be negative x plus 1 over x plus 1, x minus 1. There we go. I was stuck. Braden saved the day. Okay, I still need to take the antiderivative of that. I've still got x squared over 2 out here. I'm well beyond the confines of the space provided, but... Okay, so when those went away, that negative I'm just going to put out front. And maybe you recognize what's going on, that you don't even need a u, but maybe you want to do a u substitution to... That way, I've got du over u, or 1 over u du, however you want to phrase that. And there was no change for dx, like nothing needed to be spawned, so I'm good. All I did was slide that negative out front. So x squared over 2 minus natural log absolute value of u plus c. That looks funny because there's u's and x's in there. But it's not wrong, because you've said what u is. Again, the multiple choice is not going to look like that. It's going to plug in x minus 1. Okay, I will tell you that there is long division on the test, but it doesn't have that extra step that almost got me. So the one on the test is not that bad. Still long division, but not that extra step in there. All right, number 9. Any thoughts on what u should be that would simplify things? 1 minus x squared. Because, peeking ahead, that means du is negative 2x dx, which we sort of have. So, put the 5 out front. Put a negative 2 on there and a negative 2 or negative 1/2 out front. And again, that's how it's supposed to work. If you pick the right u, you get an antiderivative, an integral that is supposed to be relatively easy. Right? That's just power rule now. Increase the power by 1, divide by the new power. Don't forget that coefficient that's still out front. And I guess you could just put a plus c on that and call it a day, because you've said what u is and you don't need to simplify the fraction. Multiple choice, obviously going to clean that up. 2's cancel. So negative 5/3, 1 minus x squared to the 3/2 plus c. Again, most of the test is multiple choice, so that's why I keep simplifying. But for the 4 free response questions, by all means, safe stop them. Don't risk making a dumb mistake somewhere. All right, number 12. Already noted that it was tricky. And it's not like, oh, that's so tricky, don't have to worry about it. It's more like, hey, tricky, make sure you know it because you're going to see it again. I don't remember which part it's on, if it's on the Thursday or the Friday part. Any idea what to do?
Did you subtract e to the x? Did you break up the terms? Oh wait, it's 1 plus e to the x?
Yes. So you can't break up a denominator, right? If it's flipped, you can split a numerator. You know what might hint us as to what to do? E to the negative x is the same thing as 1 over e to the x. So what would I do if I wanted to clear that e to the x from the denominator? Let's multiply the top and the bottom by e to the x. So e to the x in the top, in the bottom e to the x plus 1. Again, I keep thinking ahead of what could I let u be so that du shows up and so that I get something that I can take an antiderivative of. But most people can't think 3 steps at a time. You just kind of have to pick one and see if it works. Thoughts?
E to the x.
not a bad guess, and you could get there doing that, but let's make it be the entire denominator. Because if you let it just be e to the x, you're going to end up with du over u plus 1, which isn't bad. That's still natural log of u plus 1, so that would be okay. But I think I want to just wipe out this whole thing, because the 1 doesn't do anything when I take a derivative, so I may as well grab it as part of u. So I've got du over u, which is natural log of the absolute value of u plus c. And again, that's a safe stop. That's fine. Multiple choice is going to fill it in. And when possible, why am I able to get rid of the absolute value bars? Yeah, e to the x plus 1 is always positive. E to the x is always positive, so adding 1 is even more positive. But again, on your own, just leave it. As long as you've identified u. Multiple choice, you'll have to identify which one is right.
If we didn't get rid of the bars, is that points off?
No, it wouldn't be, because it would still be accurate. It's just unnecessary. Sort of like if you put a 1 out front. You know, it's like, oh, it's not necessary, but it's not wrong, so it's fine. Let's see, that was 12. Oh, this is the easy class to keep up with because we're doing multiples of 3. So number 15, excuse me. 5th one we've done today. Number 15. F of 0 is 2. F of negative 2 is 3. And we want the antiderivative of f prime. Okay, well, the antiderivative of f prime, what's that going to be? F. So that, I think that's why they're telling me stuff about f. So I need to clean this up and figure out what's going on here, but the antiderivative of f prime is going to be f. So, thoughts on what we could do to clean that up? Let's let u be x over 2. Yeah, I'm worried about just not doing this because I know there's a chain rule thing going on here. So u is x over 2. Du then is 1/2 dx. And rather than have to deal with that 3, I'm going to split this up. Like this. Maybe I should have done that first. But I was eager to knock out this u business, and then that 3 thing was throwing me off, so we can do that separately. Let's keep working on the u thing, and then we'll come back to the 3. So I need a 1/2 in there, or 1/2 on the dx, and then a 2 out front. So 2 antiderivative f prime of u du. Be careful though. Right, we got limit things going on here, boundary things going on. So u is x over 2. So 0 over 2 is 0. Negative 4 over 2. I don't know if I should be showing these or not. If x equals 0, u equals 0. If x equals negative 4, u equals negative 2. Again, you don't have to show that, but if that helps you keep track of everything. This fits real well with what what we already know, so that's good. I guess let's keep going on this. We'll come back to that 3 in a minute. Antiderivative of the derivative is back to f. From negative 2 to 0. So 2 times f of 0 minus f of negative 2, which we have. This is not a safe stop. I've got to plug those in, but we're almost there. Now, how about this part? You remember how to... Well, there's 2 ways to do that. I could take the antiderivative of 3. That would be 3x. And then plug in top minus plug in bottom. Or I could think about what this means on a picture, the area under 3 from -4 to 0 is 12. So I'm just going to subtract 12. That's the area way. Don't like that, Elena?
No.
The other way is to do 3x from -4 to 0. And you can tell pretty quickly you're going to get 12. You're going to get 0 minus -12, which turns into 12. All right, let's finish plugging things in here. F of 0 is 2. F of -2 is 3. That would be a safe stop. -2 minus 12 is -14. We missed some of the other U substitutions on this particular page. Did them in the other classes, but I think you can tell by looking, pretty quickly. Usually you make U be the inside of the F stuff, and then kind of go from there. 13's got a picture, 16's got a table. So watch the other videos for those. Number 18. Thoughts on this guy? Yeah, but it's natural log of x squared. So, and I can't reduce here since this one's inside the x squared. So don't reduce that. How about u or something else?
X squared.
So if u is x squared, and du is 2x, but that's in the denominator. So it's a good guess, and if the x was in the numerator, it would be the right guess. But with that x in the bottom, I don't think this is going to work.
So use just x.
Can you warn us that?
What's that?
Can you warn us about
No, because that's what happens on integration. Like you false start sometimes. And so even the teacher who knows it's a false start is going to roll with it occasionally because it happens. And it's okay. Because again, to make the u substitution work, u has to work, du has to work, the integrand has to work, and you can't just keep all those things in your brain. You got to write some of it down, and then if it doesn't work, try something else. That's part of the process. Larry Tunsil false start joke right there. Algebra, anyone? Oh, someone said u equals x. You really don't want to ever do that because all that does is change all the x's to u's. And so you're right back where you started. So don't ever do that. It's not wrong, it just doesn't help. There's an algebra step that's hidden in here. Yes. Make that 2 out front. Is that not what you said?
That's not what I was thinking.
Okay. Now do you see a u-du combination that would work? Natural log of x, never just x, because that doesn't change anything. So it wouldn't be wrong. You just end up writing the same exact thing with u's instead of x's. So why did you pick u to be natural log of x? What's du? 1 over x dx, which is what we've got. Again, once you pick u correctly, you get an easy integral. So u squared over 2 plus c. And that's an okay stopping point. Obviously, you could reduce the 2's, put natural log back in there. So there's probably your multiple choice answer versus your free response safe stop answer. So, an algebra first problem. Thoughts on 21 for a U?
It's in the bottom. I don't know, isn't the bottom just x plus 1?
Okay, so this one is, I don't think I meant to do this. It is, except you have to be careful about the square root of x squared is really the absolute value of x. Ugh. And then, yeah, I don't want to mess with that. Let's just let u be not the entire denominator, because that would be too much. Let's let it be the inside of the square root stuff and hope that it works. And again, you don't really know when you first start if it's going to work or not. Does that work? Is that good?
Yeah, you take a 2 out.
Yeah, I can put a 2 on there and a 1/2 out front, and then I'm good. Oops. So 1/2. Oh, careful, we're switching from x's to u's, so I don't want to write those limits yet, those boundaries yet. Du over u to the 1/2. I also don't like u to the 1/2 in the bottom, because I'm afraid I'll integrate it wrong. So I'm gonna fix that now while I'm thinking about it, and then let's fix our limits. So if x equals 1, u equals 1 plus 2 plus 1 is 4. And if x equals -5, that one's a little bit harder. 25 minus 10 plus 1 is 16. It is your choice. You can still do it this way, but I would probably flip it around because I like the lower number on the bottom. And if you want to flip it around, the price you pay is a negative out front. So kind of your choice on whether to flip it or not. Okay, power rule. So u to the 1/2, divide by 1/2. Don't forget the negative 1/2 out front. And I've switched everything to u, so I can keep using the 4 and the 16. And I don't want to put the x stuff back in there. That's another thing that people do. They switch the limits to the u things, but then they put the x stuff back in, which would be fine if they then switched it back to x limits. Let's see, so negative 16 to the 1/2 minus 4 to the 1/2, which is a safe stop, but your Algebra 2 teacher would look down upon you if you left it like that.
But mention that later you might not.
She would? Good. Because that's fine. And in a free response, leave it.
But that might be the start of our Algebra 2 problem.
Right.
We will not lose it.
So safe stop when possible. Multiple choice is obviously going to be simplified. Oh, are we done with 21? 24. Again, I'm looking for u so that du shows up and so that my integral gets easier. Why did you pick ln x? I like the pick. Because there's a 1 over x there, so that's a good start. Like we're 2/3 of the way there. Good for u, it's good for du. Let's see what happens the rest of the way. I don't like the 7, so just throw him out front. Dx over x, that combination of things, is du. And then I've got 1 over the square root of 5 minus u squared. Okay, so that final thing is, can I integrate that? Does that look like an antiderivative we're familiar with?
That's sine.
It's sine. How did you know it's sine?
It's a square root.
Had a square root.
And it's the
And
it's minus the square.
Yeah, it's minus the argument squared rather than the argument minus 1, or a squared. So Yes, so that was a good pick for you because it works for du, it works for, we think, arc sine. A would need to be square root of 5. So 7 arc sine u over a. And we can just leave it as u over a because we've said what u is, we said what a is. This would be one where, in fact, I did this earlier today. We're running out of time, so I just wrote that as my answer. Kind of giving away the answer here. What's wrong with that? Why is this not okay? I didn't say what A is. Like, obviously you did everything right, but if you're going to use extra variables in there, you better tell me what they are. Multiple choice, they're going to fill the stuff in. And that looks kind of crazy, which is why you'd probably leave it as a safe stop if you were on your own, but be able to make the jump to multiple choice if you need it. 27, cotangent. I really don't even want to do cotangent until I've done tangent. So let's detour it. In fact, the only way I know cotangent is if I know what tangent is and I know how to get between the two of them. So integral of tangent is negative natural log of cosine. If I do that one first, how do I change it to do the cotangent? Yeah, take the negative away or change it. Change the negatives and change the cos and the not cos. Again, I really don't have cotangent memorized. I would do tangent first. Wait, before you turn the page, 25 is covered in a different video, but because you might see it again, let me remind you, properties of logs. This is a perfectly good answer. No one would change that. But if we wanted to be creative, we could do that.
Are you like finishing out something right now?
So that's math.
Yes, you guys are good. But what is cosine of x to the negative 1? Okay, careful. It's not, that's not inverse cosine. That's the whole thing to the negative 1. So that's the flip negative 1. So if we flip cosine, we get secant. So natural log of the secant of x plus c.
So would that be the multiple choice answer?
Any of those could be the multiple choice answer. That's the problem. So this is the one I have memorized. So I write that first, and I start looking for answers, and I'm like, wait a minute, it's not there. How do I algebra my way to another answer? Number 30. Arc sine, then limit is... This is what we're supposed to recognize. Right? I don't actually want to take a limit, because that would be a mess. What is this thing?
The derivative.
The derivative of f at a half. So I'm not actually going to do anything with the limit other than recognize that they're asking me for the derivative. Right? Half of the AP test, it feels like, is the 8 different ways we ask you to take a derivative. Just ask you for a derivative, dy dx, f prime, y prime, slope of a tangent line, weird looking limit statements, all just to get you to take the derivative. So be careful, don't just plug in 1/2 and tell me pi over 6. Right? I mean, that is the arc sine of 1/2, so good for your pre-cal teacher that you knew that, but I need to take a derivative first and then plug in 1/2. So you got suckered into that answer. Arc sine, we just looked at derivative of arc sine. That was 1 over 1 minus x squared. Or 1 over the square root of 1 minus x squared. Oh, I'm gonna pre-stamp this problem. Has Craig, you seen that stamp before?
No, I haven't.
Student made that for me last year. So we're done if we can safe stop, but my answer choices don't look like that. So let's make your Algebra 2 teacher proud here. Half squared is a fourth. 1 minus a fourth is 3/4. Uh-oh. What would you do next? How would you get rid of the 4? I'm okay with that. Okay. So some people would keep it, change it, flip it, and just flip it over. Other people, they see the square root of 4 in the bottom, and so you could multiply top and bottom by square root of 4. Certainly okay with that. And then maybe recognize that 1 over, what that means is we just flipped it over. So either way. That's not quite an answer yet, but the square root of 4 is 2. So 2 over square root of 3. All right, last one. Oh, speaking of code words for derivatives, what is the slope of the line tangent to the curve? So find dy dx when x is 1/4. Okay, so tangent, we haven't done a tangent yet. So tangent doesn't have a square root, and we add argument squared plus 1. So be careful, it's not just x squared, it's 4x squared plus 1. Or was it 1 plus the argument squared? Or it doesn't matter because it's addition. So I could plug in a fourth now, or I could square it out and then plug in a fourth. Oh, I think plugging in a fourth now is a good option because we're multiplying by 4. So that would be 1 over 4 times a fourth squared plus 1. 1 squared is 1, plus 1 is 1, or plus 1 is 2, so 1/2. Yes, sir.
So on arctan, does it matter which one's the A and B because it's addition? You said,
Well, be careful when you're going backwards, because u is always the argument. It'll always be the one that has a variable in it or involved with it, and A will just be a number.
But if you're finding that, it doesn't matter which one's the A and B.
So if we were trying to go backwards, so separate problem, and you had dx over 16x squared plus 1, you would want u to be 4x and a to be 1, because you want u. I guess here's another way to say it. Du is 4 dx, so 4 and the 1/4. If you switch those up and you said u was 1, then du would be 0, and then you have, I don't know what you have. So you always want u to be the variable thing and a to be the constant thing.